Hey guys, welcome to day 2 of multiplying and dividing rational expressions. We are just going to go through 4 examples of these problems, and some of them will include factoring. That's basically what differentiates today's lesson from the one yesterday. Alright, so let's start with this first problem. This one's pretty basic. We have a multiplication problem here, so we know that we can just squish these together. And again, you can always just skip the squishing step and start canceling from the original problem if you are working with multiplication. But again, I am just doing this for clarity. Now that we have squished them together, we can go ahead and cancel whatever divides out. So this x plus 2 and this x plus 2, those are out. It's like a game of Go Fish. When you have a pair, you get rid of it. Alright, so now that means we are left with 2x plus 7 over x minus 1 for our simplified answer. And for excluded values, we are going to take the bottom factors and set them equal to 0, as we are used to. So here we would get x equals negative 2 by subtracting 2 from both sides, and with the x minus 1, we would get 1 by adding 1 to both sides. So that tells me that my excluded values are negative 2 and 1. I kind of hate that rectangle. Alright. Okay, so let's then try a division problem. These first two problems are just review from yesterday. Alright, so the first thing you want to do is that keep, change, flip thing. So that means we keep the first fraction exactly how it is. 2x plus 7 over x plus 1. Oh my gosh, look how straight that line is. We flip the second fraction. So instead of this on top, we're going to put x plus 2 on the top. And then change the division sign to a multiplication sign. Alright, now we just have a regular multiplication problem, and we can start canceling some stuff. And again, the reason for that is if you're multiplying, you really are just like one big giant fraction. Okay, so now we can see that there's a 2x plus 7 on the top and the bottom, so those will cancel, and we will be left with x plus 2 over x plus 1. And for excluded values, I've said this many times and I will continue to say it many more times. Do not use the original problem for excluded value purposes because we have to flip the second fraction. We need to use the multiplication version of this problem, and that means we need to use the rewritten one. Okay, so we got x plus 1 equals 0, and when we solve that we get negative 1. And when we do 2x plus 7, we'll set 2x plus 7 equal to 0 as well. For this one, it's a little bit more work. Subtract 7 from both sides, get 2x equals negative 7, and then divide both sides by 2. Goodness gracious. Okay. So once we do that, we get x equals negative 7 over 2. And again, just leave these answers as fractions. Do not put decimals into my open math for excluded values. It will not accept it. So my EVs, or excluded values, are negative 1 and negative 7 over 2. All right. Next, we have another multiplication problem, but this time there's something a little extra that we have to do. Okay, and I'm hoping that you guys would look at this guy over here and notice that we're going to want to factor that. So we're going to go ahead and box and diamond this part of the expression, and then we will continue with our regular steps. So let's make our box. Make our diamond. So x squared goes up top left, 15 down here, 15x squared at the top, 8x down here. It's a really ugly 8. All right, let's play the game. What two numbers multiply to make 15 and add to make 8? Well, that should be 5 and 3. So 5x and 3x, that is how we will fill the rest of our box. So we are ready to fill out the outside of our box. We know x and x go here. We need a 3 here and a 5 here. And again, I don't go through factoring super slow anymore because we have been doing factoring for a long time. It's no longer something new. We should be knowing how to factor like we know the back of our hands. All right, so now that I've factored this part of the expression, I'm going to rewrite my problem, but instead of writing it with this thing, we're going to put our new version in there. So keep the x minus 2 on top, but on the bottom, we're going to put x plus 3 and x plus 5, because that's what we got when we factored that expression that was in this spot. And then we can keep the rest of it as is. All right, so now it is just regular simplifying. Remember, if we're multiplying, these two turn into just one giant fraction. So let's see what we can cancel. The x plus 5s, that's a pair, so those can go away. And there's nothing else we can cancel here, so we can go ahead and say that our simplified final answer is x minus 2 over x plus 3 times x minus 5. Okay, and now for excluded values, we're going to go ahead and take each of these. Remember, we need this new version. That was not going to do us any good. So x plus 3 equals 0, x plus 5 equals 0, x minus 5 equals 0. Again, I just took all of these and set them equal to 0. So my excluded values, when I end up solving that, are negative 3 from this one, negative 5 from this one, and positive 5 from this one. That's what I would get if I solved each of those equations. I didn't bother doing it here because they're such basic ones. Okay, and one last example, and this one is now division. So we do need to do the keep, change, flip. Personally, I'd rather just get whatever factoring I need to do out of the way first, and then we can go and do the keep, change, flip. If you want to do that first, power to you. It's all just a matter of personal preference. But either way, I'm hoping you would notice that this one right over here needs to be factored. So let's go ahead and set up our box in diamond. All right, that's a pretty good box. Well, it was until I went off the line there. Okay, so x squared up top left, negative 5 down here. First times third, negative 5x squared at the top, negative 4x at the bottom. Now we get to play the game that everybody loves. What two numbers multiply to make negative 5 and add to make negative 4? I'm hoping you guys would eventually come up with negative 5 and 1. So we can fill in the rest of our box. So that tells us when we fill out the outside that we need x and x, a negative 5 here, and a 1 here. So our factored form is this. So now let's go ahead and do what we did last time, which is rewrite the problem. So instead of we're going to rewrite this basically, but instead of this x squared minus 4x minus 5, we're going to replace it with our new factored version. Oop. Don't want that. All right, so we have x plus 1 over, not what they have, but what we found. So x minus 5 times x plus 1 divided by x minus 1 over x minus 5. Now, you could have just done the keep, change, flip thing now instead of just rewriting the original. The reason I didn't do it is just to be as clear as I possibly can. I don't want to confuse anybody, but you definitely could have just skipped to that step. So we're going to just do that now. So keep the first fraction the same. I'm not going to bother with the green anymore. And then change the sign to multiplication and then flip the second one. So now I'll have x minus 5 over x minus 1. Okay, now we are ready to cancel stuff because remember, multiplication means big giant fraction. So we have an x plus 1 pair that can go away. We also have another pair that can go away, and that's the x minus 5s. Okay, so when I cancel everything that can be canceled, I am now left with an x minus 1 on the bottom. That's the only thing left down there. And I'm left with nothing on the top. So the thing is, if you're left with nothing on one of the sides of the fraction, particularly the top, you just have to put a 1 there. That's your placeholder, because there's always an imaginary 1 chilling up there. Okay, and that is my final simplified answer to the division. And of course, we need to find excluded values. So we are going to use the multiplication version, not the division version. So x minus 5 equals 0, x plus 1 equals 0, x minus 1 equals 0. If we solved each of these, we would get 5, negative 1, and 1. So sure enough, my excluded values, that therefore will be 5, negative 1, and 1. All right, that is all for today. If you have not yet given the practice problems a try, please do so and let me know if you have any questions. You know, like, comment, and subscribe. Is that what the fancy YouTubers say? Okay, well, have a good day.